Okay, today we'll be starting section 3.5. Now we're going to take all those skills we learned in 3.4 and we're going to use these with compound interest formulas to model and solve real life problems. Okay, we'll also get to exponential growth and decay, mainly just the decay ones on day 2. Today, I think the compound interest formulas will be enough. These tables take a little while to get through. So let's take a look at examples 1 through 3. This is just the formulas that we've seen before. Remember, there's a difference. If they tell you the number of times it's compounded per year, we use this one. But if it says continuously, there is no end value, and we use this one. Okay. So in exercises 1 through 3, find the missing values, assuming continuously compounded interest. They just said a key phrase right there, right? Continuously compounded interest for this whole table. So we're using this formula for the entire sheets right here. Okay, there might be some problems where we use this one, but typically in this section, we just use this one. Okay. All right, so the initial investment, remember this means principal. So right next to this, I'm going to put P equals 2,000. That's part of the challenges of this section, making sure you know all the variables and where they go. They're giving us the annual rate, which is our R value. That's given. Okay. Now this one says they want us to find the time based on these scenarios. We could start here, but let's start with the easier one right now. There's actually kind of 2 questions in here. I'm going to put a little dividing line just so you realize there's a couple problems here. You might want to do the same. This is asking for the amounts after 10 years. Those of you in class, we did something very similar to this for our warm-up, just getting comfortable again with the formula. Okay, so let's do it. Remember, the amount after 10 years, this is really the A value, right? They gave me a time of 10, and they're asking for the A value is our question. Unknown. All right, so using this formula above that I highlighted, let's plug in what we know. A is unknown. What's the principal? It's over to the left of the chart. It's $2,000. 2,000 times E, and then it says rate times time in the exponent. So the rate was 0.045 times the time of 10 years. Okay, so this is just kind of a review problem right here. When the unknown is to the left, we're ready to roll. If your calculator doesn't put the exponent up there, you're going to want parentheses around it. It's not going to hurt to do it anyways. So I'd recommend always just putting parentheses when you have multiple things going on in your exponent. Okay? Because if you're using the caret, you're going to need that. All right, so 31.36. To usually go to the nearest penny. So that 4 is going to keep it at that 62 cents. So we get an amount, $3,136.62. Okay, so time to double. We've seen this once in 3.4. We just didn't spend a lot of time on it. And we struggled with it, so we're going to have to get better at it. So if it says the time to double, we're ignoring the 10 years. This was the amount after 10 years. Now they're saying, how long would it take to double this? Okay, so if we're going to double that, A has to be twice P, right? And P is given as 2,000. So the amount needs to be $4,000. That's why the time's different now, right? 10 years, that was the amount. Now we have a different amount. So how long will it be for the time to double? Time is unknown. Time equals the question mark. Okay. All right, so let's set this up. We'll see where our unknown is, and then we'll solve for it. I want a little more room for the algebra, so I'm going to move over here. So the amount of the return is $4,000 equals P times the E raised to the RT, 0.045, and we're looking for the time to double the principal. Okay. Okay, now hopefully by spending 3 days on problems like this, we're feeling more comfortable at attacking unknowns in the exponents. There's no quadratic formula, no linear stuff. We need other methods. The other methods would mean we want to go through those steps we've been working on, right? Isolate the exponential part. I want to get this part by itself. So to do that, we divide by 2,000. Naturally, I'm going to get 2 because of that relationship, double the principal. They said triple, I probably have a 3 there, right? Okay, we've isolated the exponential part. Next, we're supposed to convert this to a log. So to convert to log, you want to handwrite that in there, these steps. That's what you should write off to the side, convert to a log. So log base e, which is natural log of 2 equals the exponent. Convert to log. Okay, and now it's pretty much ready for our calculator. Remember, we're trying to solve for t, so I just have one last algebra step left. I'm going to divide by 0.045, divide this by 0.045, and I'll get my time. Okay, so I've got the natural log of 2 divided by 0.045. And then what the directions tell you for what they want you to round it to. I'll go to a few decimals for now, 15.403 years. So 15.403 years for this to double. Okay, so for the next problem, we have different unknowns. Sometimes you might not know where to start. If that happens on a quiz, I'd make sure you know where to start. This one, if you started at the wrong spot, though, you'd actually have 2 unknowns. So if you started by finding the time, you'd realize that you'd actually don't even have the interest rate either. Okay, so let's start with the interest rate. All right, so if you want to collect what you have, this is maybe what you'd do. We've got the initial investment. This is P. They did give us an amount based on a set number of years. They actually gave us the 2,000, and we know that happened after 10 years. So let me just kind of collect all this so you're clear what's going on. We have 2,000 after a time of 10 years. We can use that to our advantage. Okay. And we don't know the rate, but that's what we're looking for. So we're ready to plug everything in the formula now. All right, so using A equals PERT, this is what we get. 2,000, principal 550. E, and that 2,000 was after 10 years, so I have 10R. Okay. All right, so even though it's the rate, it's basically going to be the same steps as we just did because we got the variable up here. All right, let's isolate the exponential part. So divide by 550. When we do that, that gives me a decimal of 3.64. Okay. Here, if you want this little side note here, like I mentioned up above, remember we're convert to log is what we're looking to do now. So we'd say log base E, so natural log of 3.64 equals 10R. Well, the only thing to do now is divide by 10, and we're going to have our interest rate. Okay, so natural log of 3.64. Divided by 10. It's 0.129. So 0.129. Now, if they want you to put it in percent, then we'd move that over. And we could also say it's 12.9%, right? Just kind of depends on what they ask for. The they don't indicate, or it's multiple choice, you just recognize whether it's decimal form or percent. Okay, your turn to do a little bit of the work here. Second part where they want you to figure out the time to double. I'm going to let you go through this time. We're going to use this rate though. So now that we have the rates of 0.129, all right, plug in everything you have. You want the time to double. And let's use 550 for the principal. So your A value is going to be different, time to double. So don't use this for this part. Okay, so just to be clear, let's use a principal of 550. If that's going to double, then we're saying an amount of 1,100. So actually, you could do whatever you want. You could put $5 here and $10. As long as it's a 2-to-1 relationship, it's going to work out. So you can choose. If you use this 2,000, then make sure the principal's 1,000. I think you get it. Okay, so use this time, unknown, and then use the rate that we just found. Okay, go ahead and pause and give yourself a couple minutes to do this. Okay, here's your feedback on this. As I mentioned, if you were to look at in the book and look at the authors do, they'll just put P and then the amount, they'll just put 2P. Because we get the same thing. What would I could divide by P right now and I still get 2. You could choose, $6 and $3, and you divide by the 3, you get 2. So any type of 2-to-1 relationship would work for this problem, okay? All right, but we stuck to the principal 550 for the work. There we go. Here's our next step. Convert to a log. Log base E of 2 equals that. So natural log of 2, and then divide by 0.129. And we get this for the years. Okay. Just going to do one part of 3 down here to wrap this lesson up. We did the time a few times now. I don't think we need that right now. Maybe I'll use it for warm-up tomorrow. Let's focus on this part of this last problem. The principal now is unknown. Okay, principal is unknown using this rate. And then we got 8,000. And remember that 8,000 is A. Maybe we want to write it down here just so we have to look at the top. That's the amount after a time of 10 years is what they said based on this rate. So given that information, try to set up the formula and correctly for this scenario, finding P. Okay, try to plug in what we have. Grab and find, plug in, and then I'll help you from there. But go ahead and get 1 minute ahead of me. Okay, we're plugging it in the same formula right here. Okay, so here's our setup. All right, the algebra on this one's actually easier once you get everything in the right spot. As long as you remember that E is not a variable, it's just a number. 2.718 raised to that exponent, we can go find that number easily in the calculator. So when I punch that in, it's going to give me this number. So I'm going to jot down a few decimals here, 1.455. So I have P times 1.455. Okay, and 8,000. And that's why the algebra is a little bit easier for this one. Now I just divide by this coefficient and we're good. And we got the principal. Okay, so by dividing by that, my calculator reports this for a principal. 5,498 and 28 cents. Okay, that should be enough there for today. Work on that time maybe later, and then the exponential decay on day 2.